Hello, in this screencast I'm going to talk about our earthquakes lab. So for the lab this week you're going to need a couple things. I highly recommend that you print out, I'm going to scroll down. Where is it? It should be the last page. Yep. Okay, so print out the last page of this document. It will allow you to plot your earthquake locations very easily using a drawing compass. Now, a drawing compass is one of those metal tools. It has a point on one end and a pencil that you put into it, and you can use it to draw circles. Some students do try to do this with the circles in Word. However, it's not as good or exact as actually getting out a compass and doing it. Okay, so what we're doing in this lab is going through and learning how to locate the epicenter of an earthquake. The big thing to remember is that in order to pin down the location of your earthquake, you need data from 3 different seismographs. So what you're going to do is learn and review a little bit about the types of seismic waves. You are going to be practicing looking at some seismogram data to try to figure out when the first P wave came in and when the first S wave came in. And then remember, it's that time difference that helps us figure out the distance. The longer the waves travel, the longer the time between the first arrival of the P wave and the first arrival of the S wave will be. And therefore, that earthquake will end up being farther away from your recording station, your seismograph. All right, so what you're going to do to get started is to figure out the time difference between the different waves. So you're going to want to read and determine when the first P wave arrived and when the first S wave arrived. And the way to see this is that everything here is written in hours. So this is at 9 o'clock. Okay, this is 9:01 a.m., 9:02, 9:03, 9:04, 9:05. So we're going to record this in minutes. And then you want to round to the nearest tenth of a minute. So figure out how many seconds it is and then convert that into a decimal. Okay. You will be Figure 2 just shows a diagram to show that the farther away your seismograph station is, the longer the distance is between those two waves. So what we can do is we can see that as we go farther and farther away, the length of time, the amount of time between those arrival times increases, and that's because we're farther away, so there's more time for those waves to separate. Okay, if you need help trying to figure out how to do this, I definitely recommend clicking on this so you can figure out how to locate an earthquake's epicenter. All right. In the next part of the activity, you're going to be looking at these 3 different seismograms to figure out the time difference between the first P wave and the first S wave. And you're going to be recording all of this data in this table down here, and then you're going to be determining the distance to the epicenter. Now you're going to do that with this table up here. So once you figure out the amount of time that it is, you will slide up and down along this to try to figure out how long it's been. And what I recommend doing is having a piece of paper, as shown as in this video, to measure out the distance. This is shown in minutes, so 1 minute, 2 minute, 3 minute, 4 minute, 5 minutes. Let's say it's 2 minutes. If you take a piece of paper or your ruler and you measure out this distance, you can then slide your paper up and down here until you figure out where it's exactly 2 minutes, and then you would read straight down to estimate out your distance. And again, this is shown here in kilometers. All right. Then you're going to go to that map at the very end and use the latitude and longitude to plot down the 3 locations. We have Perth, Bangkok, Port Moresby, and then you're going to use the distances that you've determined to create your radius, and you're going to draw a circle around each of these locations. All right, and this is where that drawing compass comes in. So let's say one of your locations is here. This is actually down in Sydney, what we're looking at here, and we would draw a circle around this location with the point of our compass at this location and the radius, the distance from that point in the middle of the circle to the edge, that's the radius, would be equal to the distance that you calculated, you determined. And you'll draw a circle. Now where the three circles all cross, that will mark the location of your epicenter. If they happen to overlap in such a way so that there's an area that's covered by all three but they don't intersect, then use that location, that area, to estimate out your location. And if they don't quite come together, then you can actually try to estimate where they would come together if the circles were a little bit bigger. Okay? Now, after that, you're going to be going through and you're going to be learning a little bit about the magnitude scale. So this is the original magnitude scale. Not looking at the moment magnitude scale, but you're actually going to be reading this diagram back and forth to try to understand the sizes of our earthquakes. To do this, with the Richter scale, what we're doing is we're looking at the distance on this to scale, or you could actually look at the time difference between the arrival of the S and the P waves. And then we have the amplitude of the wave. So this is the height. What they're trying to show you here is that the waves were 24 seconds apart. So I put a dot here. And then the amplitude of the highest wave was here, reading across at 23 millimeters. So they measured up to about 23, put a dot here, and then using the ruler, they drew a line between those two dots to get a magnitude of 5. Now, an earthquake that has a very high interval between those two arrival times will have a smaller, large amplitude, and so it'll read down, and it's where the line crosses that gives you out that magnitude. So what you're going to do is use the distance that we've given you, and so I've given it to you in kilometers, and then you're going to see that the maximum amplitude is 40. You're going to plot those two and then draw a line, and where they cross will give you your magnitude. Okay, and then I have some things to try to get you to think about. If you know the magnitude, let's see. Okay, so for this one, it's going to say a second seismograph for the same earthquake from question 11, but it has an amplitude of 3. We want to figure out how far away the seismograph station is, so you're just reading backwards. It's going to be a slightly different line. Okay, and then we're going to talk a little bit about the differences in ground motion and the amount of energy released. And just to kind of put that up here as a reminder. So we get, you kind of go through and you can read through this whole area to try to figure out what your difference is, but we're actually looking at just differences of increasing by 10, or if we're going to be increasing by 33. Okay, so it's all just a matter of how much we raise it for those. Okay, and then we'll be doing the modified Mercalli scale. In this part of this activity, you're going to read through these descriptions and decide what you think the modified Mercalli scale should be based on the descriptions above. Everybody will get slightly different answers, and that's totally normal. All right. For this question, you'll be using the map. This is also in the appendix if you're using the paper printout. And you're going to just be estimating out the future risk for different areas in the U.S. And then finally going and actually investigating some current seismic activity to figure out where or confirm where our most active places are in the U.S. and why. So we're trying to relate this back again to plate tectonics. I'm going to leave it there. It should be pretty easy to get through this lab. If you have any questions, please post them to the I Need Help discussion. With that, you're ready to go. I wish you luck and happy learning.